Second talk of the day, Steve Corp from Evolvere, amazing company. He's going to be talking about network automation in financial services. We have a... We're okay? We're good? No one died. After this 20-minute break, when you get into the break, please try and be back at the end of the 20 minutes quickly. You can go and get refreshments in the back, use the garden, go out the front, have a smoke, whatever you want to do. Big round of applause for Steve, please.
Hello everyone. Just a word about us. We started up almost 10 years ago now. And we were 3 contractors working at Barclays, and we were given a brief of automate the network, and that was it pretty much, which we did to some extent. We still work with Barclays as a customer. We set up the company, and since then we've continued to do network automation for various clients. We've also branched out into DevOps and automation across infrastructure generally, not just networks. We've joined the CNCF. We're very cloud native focused. Sort of our emphasis really is to bring cloud type a cloud type operating model really into the hybrid cloud world, and we're working on products. First product is probably going to be released around September time. So a lot of our customers are in financial services just really because of our background. So I'd worked for probably most of the companies in Canary Wharf at one stage or the other. My 2 partners have both worked in that space, so a lot of our early customers were in that area. What I wanted to talk about today was the challenges of working with these customers. It's probably not that unique to IT services, to be fair. It's probably similar for just any large enterprise. And the customers that we work with are the big established players rather than the fintechs who are probably, you would think, more agile and already doing a lot of this kind of stuff. So these are go through some of the challenges, and so as not to send us all into a spiral of depression, I'm going to give some of our ways of overcoming some of these problems that we've come across over time. Seeing as it's a NetBox gig, source of truth, first one. So in our experience, these companies have many sources of partial truth. So they'll have whatever their IPAM system is. They'll probably have server information that the platform team maintains separately. It's all kind of distributed. The nice, neat, one single source of truth, in our experience, doesn't really exist in these companies. So that leads to duplication, conflicting information, that kind of thing. So companies that have got NetBox installed are obviously off to a good start because they're going to consolidate all of their network information at least in one place. Approaches we've taken to help with this is gather information from the network, because that is the as-is information. What's out there and running is as-is. You can gather information from other sources, reading from databases, if their systems have got APIs, ServiceNow even, and you can consolidate that in a database as a cache kind of thing and try and make better sense of it. We're also working on, let's say, NetBox integration. Some of these might be presented as a NetBox plugin, others not. So we've been asked to do things like produce a dynamic Ansible inventory from NetBox. So we've got that working. And several customers actually have got this kind of problem where in their internal IT system, they've got a good view of their networks, but in their cloud environment, they've got no idea. So we've written some code that will go and get that IPAM information from AWS. And typically, some of these big customers will have lots of accounts, so it's not a trivial thing to do that, and then post it back into NetBox. Standards. So when I was doing this, someone pointed out to me that these snowflakes are actually identical, which wasn't really the story I was trying to say. Yeah. So standards, yeah, there are lots of them. Big companies will tend to have, well, we had our Gen 1 data center standard, then we got new hardware, now it's Gen 2, 3, 4, and there's some of them all still existing. There are snowflakes in there because big enterprises have lots of applications, hundreds or thousands even, and when application teams go to deploy it, they'll usually, if there is already a deployment model, they'll say, well, none of those fit our applications because we're special, or they'll just want to do their own thing anyway, so you get lots of snowflakes. No service catalog. So recently we've taken on a customer who's actually a service provider, and there's a stunning difference between an enterprise and a service provider. The service provider knows what their services are because they provide them and they're directly in the front of the business. Big enterprise, got loads of apps in there, don't really know what the services are, you know. So some automation products that are out there that are service-based just won't work in that environment because you don't know what they are. Things that we've done that sort of help out in this area are, again, sort of I think Pete mentioned it before, that, you know, the read-only kind of stuff, they're safe operations to do. So we've written modules, Ansible modules that will go out and collect configurations and compare them with what your standards are, so you can get a compliance view on how good or otherwise it is. Change control, yeah, we all love that. These organisations tend to have a low frequency of change. You know, it's all the build up all the changes into one massive weekend. Technical reviews are kind of interesting because what we've seen happen at these is the technical review is done at the change advisory board meeting, which shouldn't really be the case. The board meeting should be about, does this change conflict with that one, not is this haystack of XML valid or not. And there's a tendency to impose change freezes, not just at end of year, but also sometimes in response to changes that have failed. There'd be a bit of a knee-jerk, well, let's freeze everything kind of reaction. So that's a bit of a hostile environment for automation. So we have had success in these environments, and by starting with low-risk tasks, and this isn't always a bad thing because quite often the frequent tasks are the low-risk ones anyway, and so automating them, you can actually save a lot of time. It's interesting actually, Pete's talk also about describing the business value of automation. As we found early on, automating a BAU task, our sponsor was the ops manager, and when we'd done it, we thought how great it was, and he went sort of, meh. That's a bit meh. It's a bit less for my team to do, but we don't really care. The actual benefit was to the end users of that, because it was an end-to-end service and self-service. Things that they had to wait for this team to do, they could just do straight away. So, the saving wasn't really in operations team time, it was the consumer's time. And if you could put a metric on that, that would add up to a lot, because all that wait time would add up. Test and development systems, yeah. So I've taken in my career path, gone from network engineer to doing more programming. I would say I'm not really a network engineer anymore, because I'd probably be the last person in this room you'd ask to design a network these days. So it's quite jarring how the difference of attitude between networks and code is. As a network engineer, you've probably done this before. You build a long text file of config. You get your change window, which might be like a really social time, like 2 a.m. on Sunday or something, when you're actually at your peak performance. And you go, paste it in, and the first time you paste it in is the first time you ever run it. So, I mean, you wouldn't write one line of code without testing it, but that was my experience in networks. There might have been a test device somewhere in a lab that had a version, like 3 versions back, and was barely alive with one power supply that you could test on. So that is a problem. Ways around that, there are lots of virtual devices now available. So some vendors provide pretty good virtual devices that are more or less the same as the real one. Input validation is a big thing to test, because users can put in anything, and you've got to make sure that what goes in is correct in the first place. Automated pre- and post-testing. So this is helpful for just validating that what you expect to happen has happened. So if you're changing something, take something before, take something afterwards, and you can build that into your code to do that. Doing the actual comparison might be a harder step, and maybe you don't really need that. But at least having the data there collected automatically. And robust error handling. So as well as finding out what's happened if it fails, also need to make sure it fails safely. We had a customer recently, who I won't mention, they were pasting changes in through Postman, like a big metric ton of XML, or JSON, I think it was. And they were putting, I didn't even know you could do this, they put in JavaScript in there, into this massive paste thing. And when it failed at the step where it says, and now delete everything. That went well. Don't know if any of you, some of you probably weren't even born when this came out.
I have really old gear. I retired serial number 3 of those.
I was going to use, when I was looking at pictures actually, they had some where it was all open, there's all like wires and stuff hanging out. I thought that would be a good one. So you get a lot of this, legacy systems, they've got no API, no one wants to walk near them, let alone log into them. So read-only automation is your only tool to use here, really, because you can't, it's just too risky and too much effort for the gain to start automating this stuff. We did have, someone asked us to, can you automate this switch running CatOS, if you believe that? Really? I think it was Telnet as well. So observability, so, that's something else you can do. We'll come on to that a bit more about collecting metrics and doing stuff with it. Technology silos, we've all seen this. So one of the things that we've benefited from is that because we now look at DevOps tooling, so CI/CD, all of that kind of stuff, and across platforms, so not just networks, servers and everything else, we get a broader view and we can share ideas, and our own company is like an internal community. So people that are forced to live in silos don't really get that opportunity, and a lot of our customers work that way. So doing anything across silo is difficult, and that's where a lot of the business value is. business team might want to get their application deployed. They want servers, network storage. They don't really care about anything else. So you've got to break through these silos at some stage. So yeah, ways we've addressed that are API first strategy. So I think when our first project, bearing in mind, like Ansible wasn't even a thing, I don't think, when we started, or it was, but there was no tower, this kind of thing. So we wrote kind of like self-service portals and that kind of stuff. We're moving now towards an API first strategy. So partly because we're rubbish at writing GUIs, and partly because if you present your services with an API, then anyone can consume it. Which leads into self-service, so you can present, if these guys present services at the top via an API, then the other silos can use it. Bearing in mind you need to have authentication, all that kind of thing. And I think this was mentioned before, building a development community so that if these silos have some community that sits over the top, they don't each have to invent solutions to basically the same problem. You can set up sort of a common library of routines you can use. Security policy, yeah, you have to have them. They're the team that says no. And quite often we found they've got a company will have an infrastructure that all of their equipment fully supports APIs, but they're all disabled because security says no. Jump hosts, so you have to get anywhere, you go through a jump host first, and this can sometimes be an ancient machine that used to be a management machine. It's probably running Solaris or something like that. And they'll put limits on the packages and versions, so if you need to get a VM installed, that can be troublesome, and then getting the right packages you need on it can be even worse. Only the old ones with bugs that are well known. Well-known deficiencies seem to be okay for some reason. Yeah, so getting around that. So Ansible can help because you can delegate. So as long as this host isn't too ancient, you can run Ansible packages on it. Platform engineering is something we'll talk about, which is a bit of a new hype topic. Oh yeah, the again was in the wrong order there, never mind. Runtime environment, so getting your code, you can solve a problem, but how do you get that code run? So Ansible is a good way because it's pretty ubiquitous, it's certainly amongst our customers. But if you're trying to do something outside of that, it can take months to get a VM provision sometimes, and then you've got all the rest of the provisioning type problems. So that's a bit of a sad tale of woe, really. So let's look at what we can do. Observability. These are areas, rather than talk about individual projects, these are just general areas where we've seen success in this environment. So I don't know how many of you are familiar with Elasticsearch. We've done a lot with Elasticsearch from projects that just involve Elasticsearch, like migrations, that kind of thing, and actually using it ourselves. So if you're going to collect information, then storing it in Elasticsearch is great because it's like a JSON document format kind of database sitting on top of here. It used to be called ELK because you had Logstash. This thing in the middle is the Elasticsearch database itself, and then something called Kibana is like the graphical interface to it. So if you get data into Elastic, you can use Kibana to do all kinds of dashboards and analysis, and all of that's out of the box, so you don't have to really, it's not a coding exercise to do that. So a couple of ways you can get data in there. So Logstash is a utility from Elastic themselves, so you can get syslog data into Logstash. Logstash has got lots of different ingest methods for different types of data. We've done projects where we take syslog data. In Logstash, you have the opportunity then to pull out fields from that text using filters. So they're called grok filters. They're kind of like regex, really. Other ways that Elastic itself has these beats, a beat structure. There's one called file beat, which will monitor a file system. Metric beat, which I think is to do with like server metrics, that kind of thing. We've written our own framework for posting directly into the database. So this method, this way in, Logstash will post into the database. EvoBeat will post directly into the database. And we've written that because for some data, there isn't an easy way to get it. So the only way, if your only way to get the data is to log on into the device, do something, collect the data and post it, then EvoBeat is a framework that takes care of all that posting side of it, so you can just concentrate on your code that goes and gets the data and formats it. Because we had to do that quite a lot. Ansible, this was mentioned before. I picked the nice sort of turquoisey colour at Ansible instead of the black one or the red one. Yeah, I think, I mean, from ubiquitous, obviously I don't know what every company in the world is doing, but our customers, it's pretty much, they're all using it in some way, maybe not uniquely, but with other tools as well. Simplifies is probably the wrong word there, because you know, it is quite difficult sometimes to get playbooks and things working, but it is a way of packaging Python scripts. I think there was discussion earlier about should you write just Python or should you write modules. So yeah, the answer is, of course, it depends. But if you've got some code that you think is going to have a lifetime beyond just a few months to get something done, and other people are going to use it, then Ansible offers good ways to package that. So you can do that. We've used it for things like the config compliance reporting, so we could package code that does that as a module. Inventory validation, so things like going to check in LLDP neighbours with what's actually in the inventory in case you find things. One customer, and I really can't mention this name because they're a retail bank, and in their inventory they had about 800 devices, but in the actual network they had about 1,300 devices, so they had 500 they didn't know about anyway. Health metrics, reachability, sometimes that's useful to, you've got an inventory, but can you ping each device, can you SSH to it? Cisco ACI, so I should think most people here have heard of that. Horrendously complicated under the covers, well, and on top of the covers, I think. A lot of network people hate it, and I can see why. But it is a software-defined fabric, so no more SSHing to individual devices. You go to the APIC, and it's really ideal for automation because everything you can do. When you're using the GUI front end, it's driving the API. So everything is API driven under the covers. They've got some useful tools in there, built in there to help you do things like discover what's going on with the API. It's got this huge object model, thousands of things in there, and you can look at each object type and all the attributes. So yeah, so we've done a couple of things with this. We've done a couple of big ACI migrations, so moving from legacy to an ACI fabric. So we collect the data from the legacy, then take that and use the information from that as parameters to code that goes and does bulk configuration on ACI. We've also done a bit of event-based automation, so ACI offers you the capability to subscribe, so you can listen to objects, and you get updates when they change. So you can then listen, you can have some code that's listening, maybe storing the data as state data somehow or the other, because you'll just get events dribble in and out, and then you've got opportunity to take actions based on that. And health metrics, that kind of thing. Future trends. So I was going to mention AI and ChatGPT here. But no, I took it off the presentation. Telemetry. So telemetry. So what even is telemetry? So there is an RFC on it. So when you talk about that, my feel of telemetry is it's more sort of like push-based metrics. So something on the device itself is collecting data and it pushes it in a near real-time kind of basis, rather than you going polling via SNMP or that kind of thing. But it's a bit of a vague description. And there's also lots of different ways of implementing telemetry. So there's no agreed standard at the moment. But we are looking at it. It's come up as something that people are interested in. Machine learning, again, this is early days, so if you believe the hype, we'll all be taken over by Arnold Schwarzenegger Terminators pretty soon. But in actual fact, you have to put a lot of effort into machine learning to get anything out of it. So again, early days, so very much not expert in this area at all, but from what we've seen, if you've collected the data, that's the starting point. You then have to decide, well, what question is it that I'm asking? Which fields of this data are relevant to that question? What time period do I need to look over the data to spot cyclical kind of trends? Then you build your training data, then you apply it. So, it's not just press the machine learn button and it'll come up with answers for you. And it's as, companies have to decide really how much they want to invest in it, because if you go with it, are you going to need an army of data scientists then to keep it going? Mentioned platform engineering a couple of times. So this is kind of a bit of a cross-fertilisation between our DevOps side of the house. So I think platform engineering is going to be another one of those things like DevOps where people spend about 5 years working out what exactly it means. So what we take it to mean is it's building a platform which is a set of tools that lets you deploy your code. So the difference between some of the differences that make up the platform engineering definition are you build this platform and you treat it as a product. So what that means is you need budget to keep it going, like an OpEx budget. Did have a customer recently, quite a big one, and they're talking about how do we automate everything. It was a bit one of those vague, just automate everything kind of conversations. And someone actually said, so the thing is, when is automation going to be done then? So yeah, I didn't really want to bring it to him that it's never done. You start on it and then you can't stop. So with this, you look after this platform like a product, which means you add new features to it, you have continual budget and development of it, and this product is your software delivery pipeline. So why is that relevant? Well, if you're going to run your network with software, then you need to look after software. You need to do it like software teams do, pretty much. I think in the previous session, there was this kind of discussion, well, are we networks, are we software, where does that split go? And the further you go into software, the more you're going to have to do this to just professionally managed software. You need to be able to deploy it quickly. You need to make sure it's stored in repositories, it's all looked after properly, it's tested, all of that kind of thing. These are the products we selected for a test IDP, as it's called. So platform engineering is about building these IDPs. We use Kubernetes quite a lot, and Rancher is a Kubernetes orchestrator. In our example, we use Jenkins for CI/CD. There's other options as well. Container registry, Elastic as our observability platform, and then some of our secret sauce, that's not secret actually, to join it all together. So that's it. That was a bit of a whirlwind. Hope you enjoyed it.
Alrighty, we're arriving with the microphones. Thanks, Rich.
Thanks, Steve. So, 2 questions of things that I picked up on. You were talking about AWS gathering information there.
Yes. Yep.
So, can you expand on that? And then question 2 along that, telemetry, right? What have you seen anything more than just an alternative way to gather those same stats? Or people trying to get other information out of telemetry?
Yeah.
Any comments on that? Thanks.
Yeah, okay. So the first question, sorry, what was the first question? AWS, yeah. AWS. So AWS has got its own language for automation. You can run the AWS CLI, there's CloudFormation and various things. So it's already set up, really. So there's a Python SDK you can use, which is what we would use, but there are other languages as well.
Maybe I'll rephrase the question.
Yeah.
I don't know if I should use the mic or not.
I'll repeat.
Speak loudly. Yeah, thanks.
I'll repeat, yeah.
Okay. What was the case for getting information? Was it just basic inventory, IP addressing, sorting out overlap of IP addresses? Yeah, what was the reason you needed to get that?
Yeah, so the reason was, so this is hybrid cloud environment, so they had an established on-premise infrastructure, or have, they're still in business, hopefully. And the network team there, doing all the usual stuff to manage that. AWS has been added and slowly grown, which is probably quite common. And so now they've got 40, 50 AWS separate accounts, because they have different accounts per BU. And then the network team has taken over network responsibility for this gradually. They've said, they've set standards for, this unit should have this IP address range, this one, that one, etc. But they've got no way of really policing that or really knowing what's going on. So that was where the requirement came from. So what we did was write something that will talk to AWS using those Python modules, get the IP prefix information back, and then post it somewhere so that they can say, oh, okay, you're all using the same network, 172.19, whatever it is, why is that? And actually pick out things that are wrong. We've had this is the second iteration of it. We did it a few years prior, but we did it more as a sort of one-off rather than a reusable module. And they said, oh, it's okay, it's all sorted. We've set it all out. These are the ranges. Ran the script, nothing like that. It's all over the place. So that was the reason for it. And I think this is probably quite a common theme, is where companies have got an internal IT team, and then they bolt on cloud. They have to they might have a cloud engineering team, but they've got to work together at some point. And there's some information exchange needed, and if you can help that, then it gives them a better picture. And the other question was telemetry, yeah. So we've looked at open telemetry, and open telemetry seems to be about providing an SDK so that coders, application coders, can put hooks in to their code so that they can report latency and metrics through their application in a standardized way. Telemetry in the infrastructure space isn't that. It seems to be telemetry is vendor-specific implementation. You need the vendor-specific client to listen to it, and you're also restricted as to what metrics you can actually get. So that's dependent on the metrics the vendors are going to provide, and you probably have to configure it to provide those as well. So I guess the question is, well, why bother with that then? Why not just keep with the metrics you've got? I think if there's metrics that are provided that you need, and telemetry offers the capability of getting those without polling for them and all the overhead of that, then that's probably the case for it. But I think it is still very early days, really, with telemetry. And it's not until the number of metrics expands and hopefully it gets standardized, although I wouldn't hold your breath for that.
Hey.
Hello.
Hey, Sebastian from NextPacket. I can relate very well to what you said in the beginning around there's no single source of truth.
Yes.
So many organizations just have so many sources of data, and all of them are relevant for the network configuration. Did you apply some specific methodology on how to approach this, like QED or?
Yeah, unfortunately not, because it's very customer dependent as to what these sources are and their relative importance and how they use them. So at the moment, it's a sort of a bespoke kind of thing, working out where these sources are, where their CMDBs are, what they actually are. If they're modern-ish and they've got an API, then we can draw on them. Some of them might not be that modern, and it's more difficult then to get the information. So no, unfortunately, there's no real methodology. It's all on a case-by-case basis. I suppose, actually, if there is any methodology, what we've done before is when we collect the data, we'll put it in something like a Mongo database. So that's easy to use because it's no SQL database. You can add fields quite easily, and then we can start work on collecting the data while we're still talking to the customer about what is it that you want with this data, how is it related, because we don't have to make architectural decisions day one. We can start collecting it.
So we've got time for one more quick question, if there's another one in the room. Yep, Dan.
It's a very quick question. What was the Cisco device on your slide?
It's an AGS Plus, I think it was. Yeah.
What's that?
Yeah. What is that? I think it is one of the, if not the first, it's one of the early. Is it the first one?
Yeah, ask him.
Yeah.
Go Google how the source code was stolen in the lawsuit about that. Yeah, there's a whole thing about that.
There you go. It's like Cisco's first router, I believe.
All right, that's all we've got time for. Another big round of applause for Steve, please.